Our second device that we're going to study in the area of mechanical computing devices, we're going to fast forward hundreds of years to the year 1640, where a gentleman by the name of Blaise Pascal invented what he called the Pascaline. Um, Pascal, by the way, is the name of a computer programming language that was named after this mathematician, so a very famous person in the world of math and computer science. The Pascaline made adding and subtracting extremely easy for anyone to do. This device was mainly used in stores of the day, so they would add up. Either a customer could add up all their purchases and be told what their total would be, or maybe the store owner would add up all their sales, all the receipts that they had written down for the day to find out how much money they had made or how much they owed maybe someone else they had bought those um, parts from. But this was mostly used for retail stores in the mid 1600s. Um, and the way it worked is it eliminated one of the drawbacks of the abacus, and that is you still had to kind of do some mental math when you had to add 10, take away 7, add 5, take away 2. It still was a little tricky for people to do that without thinking about it. So this actually eliminates the thinking aspect of it, basically. Here we have a picture of it. I think this is from a museum. And here we have the inside where you can see all the gears. The way it works simply is when you turn these dials to your different numbers, an actual number would appear in this window up here, an actual 3 or a 5. So you didn't have to count beads. It just said 3 or 5. So it made it much easier for people to put numbers in and read them. Now, the way you would turn these dials is they actually use a device very similar to what we would use today, a stylus. Maybe you've used a stylus on a tablet or some sort of device that requires you to use a stylus. But the stylus would be put between these little spokes and turn these dials around. Very similar if you ever use an old rotary telephone from maybe the 70s or 80s. Very similar to the way that operated. You would put a number in, turn it around until it stopped here. Now I have a short video here that I'm going to use to demonstrate the workings of this little animation here. I think I'm going to narrate it because the gentleman that narrates it does it very slowly. So let me kind of just back up here. So here you see the stylus, and he's going to do a simple number. He's going to put in the number, I think, 28. So he puts the stylus in the 2, pulls it down till it stops, and lets go. A 2 gets turned over in the window. To put an 8 in, of course, that's the tens digit. In the ones digit, he puts it in the 8, and he pulls it around very slowly, apparently. You could go much faster. Until it says 28. So he's put in his first number. To add a number 35, he simply puts another number in and turns it 3 more. And that's going to spin the dial up to a 5. Now, again, we eventually need a 6. The carry operation is done automatically. So when he goes 5, when he goes past the 9 to 0, that automatically went up to 6. And this comes back around to 3 to give him his total of 63. So you can see how much easier that was. Still primitive compared to what we would use today, but so much easier than the abacus because you just put the number in, turn the dial, put the next number in by turning the dials, and your total, no counting or adding or counting beads, anything like that. Now, that was adding. To subtract a number, what he would do, let me skip forward in the video, is, okay, you can ignore all of the math. This little bar up here, notice that there is a bar hiding something. Well, if you slide this bar down, it reveals another set of windows. And these windows are going to show the subtraction values. So he is now going to perform a subtraction here in a second, eventually, when he gets around to it. Okay, he's going to put number 31 in, just like he did before. And now he puts in 1. Notice it went down to 2 instead of up to 4 because it's in the subtraction line. And then 6 pulls it. Notice counting backwards, 8, 7, 6, and it stops at 5. So just by moving this bar up or down, performs a subtraction or an addition. So that was used in the middle of the 1600s for, oh, one more thing I want to show you is the gears behind this. It's kind of interesting to see what's inside of this. Let me back up to fast forward. So this is the gears, how they translate. If you kind of want to know how that works inside, you have some horizontal gears that gets translated to a vertical gear down here, which goes over to this axis, which can turn the windows over here. And it's some very unique engineering, especially when it counts the carry and has to figure out how to or when to carry. You can see how this operation is, how this is how the ones digit is affecting the tens digits. So anyway, that is the Pascaline and the creative engineering behind how that works. You can see it now in full operation, showing how the dials are turning these gears. As I mentioned, this title was mechanical computing devices, and this is as mechanical as you can get. There's just gears and spokes and dials. So this is the Pascaline. So for your notes, you need to know the guy's name, Blaise Pascal, 1640, Pascaline, and its purpose was basically to add and subtract values sold at a store. And that's the next modern invention um, in the purpose of creating devices that would simplify calculations and perform them more quickly and accurately. And so that's the Pascaline. That's the second device out of our four in the mechanical age of computing technology.